So picking up where we left off, let's write the Lewis structure for, what's the name of that ion? ClO minus. It's related to chlorate, right? It's related to chlorite, but it's even below that, hypochlorite. Okay, so doing Lewis structure, we need a skeleton structure, just how the atoms are connected. This one's easy because there's only 2 atoms. So the chlorine and the oxygen must be connected to each other. So there's chlorine and here's oxygen. And what's the next thing we have to think about? How many valence electrons? So we need to figure out how many valence electrons we've got here. How many valence electrons does chlorine have? 7 valence electrons. That's awfully fat. 7 valence electrons. And oxygen has 6. Thank you. And then there's this negative charge. That means we either add 1 or subtract 1. We add 1. If the ion has a negative charge, that means it has an extra electron. So we add 1, and that would give us 14. So we have 14 dots that we can put on this guy. So we're going to start with a bond between. So there's 2 electrons between the atoms. There has to be a bond there. So that's 2, and then we distribute 2, 4, 6, 8, 10, 12, 14. Nice, we had enough to go around. There's one more thing we have to do though. This is an ion, and so we need to put brackets around it and write the charge. Because without the charge, it's the wrong number of electrons. Now, mastering chemistry doesn't do the brackets, and there's at least one question, I think it's a sulfate ion, that gives people a lot of problems, because when there's more than one charge, mastering chemistry wants you to put it on different atoms. Okay? Because that charge would be spread out, it would not all be concentrated on one of the atoms. So I'll just tell you that on the sulfate, it wants a -1 charge on one oxygen and a -1 charge on a different oxygen instead of -2 on the same oxygen. Any questions about this problem? Now, there are exceptions to the octet rule. There are some molecules that it is impossible to write a good Lewis structure for. Lewis theory does not explain everything. And we really can't expect such a simple theory to explain everything. It works most of the time for certain things. What if we have a molecule with an odd number of electrons? So NO is a valid molecule. Nitrogen has 5 valence electrons. Oxygen has 6. 5 plus 6 is 11. That's an odd number. There is no way you can write a Lewis structure for NO, nitrogen monoxide, that has an octet for each. And so then what we do is we just do the best we can. So this is the best situation where the oxygen has 8 electrons, an octet, and the nitrogen has 7. So that's one example of times when we have exceptions, when you have an odd number of electrons. Another more important exception is boron. Boron is one of those smaller elements. Boron tends to form compounds with only 6 electrons around the boron instead of 8. So the boron here has 6 electrons. It does not have an octet. That's boron trifluoride. Boron trihydride, again, the same thing happens. And so in chemistry land, we kind of make allowances for boron, and we say, well, you know, he's kind of small, so maybe that's okay, right? So boron tends to just have 6. I mostly just telling you about these exceptions, and I do not plan to hammer you with them on an exam. I just want you to know that they do exist so that if you go on and take Chem 1 and they're start talking about all these things, you won't feel like I lied to you. Although I have. I have lied to you. Another exception is some of the larger elements, like sulfur and phosphorus, can have more than 8 electrons around their central atom. These are called expanded octets, and this gets into theories about the electrons that are way beyond the scope of this class. But phosphorus and sulfur can expand into the d orbitals of that third energy level, and so that's what makes it possible for them to do that. So here, the sulfur has 12 electrons and phosphorus has 10 electrons. But even with these exceptions, Lewis theory is an awesome thing and helps us to understand chemical bonding.